Okay, so jumping into 7.4 now. Again, we're going out of order than the book suggests, because I teach factoring just a little bit different than maybe traditional methods. So you'll have a nice mix between the book and myself of how you want to explore factoring. In fact, I call this section 7.4 most. We're going to cover most of the material right now in 7.4. A little bit later, we'll hit the leftovers. Factoring is one of those things that people either get it and love it because they love kind of the puzzle aspect of it, but some people, this tends to be the hiccup point, the tripping up spot, where math seems to become almost undoable. So what I've developed is a way to talk about factoring that kind of puts us with the LifeWise health insurance claim of being boringly good. We're just going to establish some steps that we use every time you're asked to factor, and we're just going to repeat those steps over and over again and become boringly good. It eliminates the guess and test, that kind of thing. Now, if you have been successful in factoring in the past, then you don't need this boringly good factoring strategy. You just probably need to refresh on a few things, try a few problems, get back into the swing of things. If you recall factoring as something that was not a good experience for you, then give this a try and see how it fits. For some of you, you're going to find a mix of things where you're going to like and be able to use some things I'm suggesting, and then take some pieces from the book, maybe from some other strategies you've been exposed to, or something your classmates or your friends, your tutors have come up with. So let's work through it. Make sure always to take good notes, bring your questions to class, and let's help you get through and become really good at factoring. Okay, so let's recall, what is factoring? Factoring with algebra, with letters, is going to be the same as with numbers. And so in not so technical terms, factoring is breaking something down. We're breaking it apart, but we're breaking something down into its most basic multipliers. So breaking something down into its most basic multipliers. Okay. Another way to think of that is we are undoing the multiplication. We're looking at it before the multiplication happened, or also the foiling, or the distribution. So before those things happened, what did it look like? That's essentially what factoring is. So here's our steps, and again, I'm gonna start running these into the ground. I'm gonna sound like a broken record because our goal here is to get boringly good. We're gonna be right on that line where we just have done it the same way so many times, we hardly have to think about it, okay? Our first step is gonna be to check for the greatest common factor, and that's what we practiced at the beginning of the chapter 7.1a, our previous section. This is an always, first thing, no matter what, even if they don't remind you, okay? Always check for the GCF. There's going to be several problems as we get started here that won't have a GCF necessarily, and you might forget. So we want to just train ourselves to always check for it. And hopefully I can be a good example of that. Sometimes I even forget. I get excited about the problem ahead of me and I forget. So we always want to check for the GCF. Always, always, always check for that first. The next thing we're going to do is ask ourselves, how many terms are we looking at? How many pieces to this problem? And there's going to be three situations. You're either going to see two terms, and this is, again, after we've pulled out a GCF. This is looking at the leftovers. Remember in the previous section when we pulled out the GCF, I said don't worry about the leftovers. Now we're going to look at the leftovers and determine if there's more to factor, if there's a way we can pull that out. For example, when we had 10 and we looked at, well, that's 2 times 5. Well, 5 can't go any further, 2 can't go any further. But let's say you had, let's say you had 30. Well, then if you did 2 times 15, the 2's done, it's prime, but the 15 can go further, 3 times 5. So this is kind of what we're doing here. We've pulled the GCF, we're seeing if it can go further. And our three options are if there's 2 terms, 3 terms, or 4 terms in the leftover. And we're going to approach each one with its own specific set of steps. Today is when we're going to talk about the 2 terms in this lesson right now. Okay? And 2 terms, it has to fit into one of the special formulas. If it doesn't match one of the special formulas, you're done. So it either matches one of the special formulas that we're going to look at in just a moment on our notes, or it doesn't, and then you're done. Now, in the next set of video lessons, which, and so this is section 7.4, in the next set, 7.4 most is what I should keep my terminology straight here. In the next thing we'll look at is we're going to skip the 3 terms for now. That tends to be the one that trips people up the most. And we'll look at what happens if you have 4 terms. And this is something that we will do later in this set of lessons. Later today is what that says. And this is from 7.1b. We're going to pick up that rest of, I'm sorry, not later today. This is in the next lesson. We will begin with 7.1b, how to deal with 4 terms, okay? And it's known as factoring by grouping. And I'm guessing probably when you were first taught about factoring, your last exposure to it, you were then, no matter what order you were taught in, if you were taught the special formulas last or factor by grouping first, however you were taught that, you were probably taught that 3 terms was its own special deal. And you may have been taught how to fill in a box or how to kind of write the parentheses and guess and test to kind of figure it out. And it felt like a puzzle that sometimes may not be solvable. So again, this is going to be in the next set of lessons. And this is 7.2 and 7.3 is what we're going to cover here. My process of teaching this is once we get good at factoring by grouping 4 terms, we're going to go ahead and convert that 3 terms to 4. And then we can just use factoring by grouping. Okay, so we're going to memorize some special formulas. We're going to get good at factoring by grouping, which is when you have 4 terms to deal with. That kind of got muddled over there, sorry about that. 4 terms to deal with. And then we're going to finally finish things off by looking at what if there's 3 terms, we're able to convert it to 4 and then continue to use factoring by grouping. Now, again, this is not the only way to factor, but this is the way I teach it, hopefully to help those of you that struggled with factoring in the past. Again, if you did not struggle with factoring in the past, you're good to go. You just probably need some refresher, practice some problems. Go ahead and dive right in and see how you do. For those of you that struggled in the past, maybe this will help. And again, if you're still struggling, of course, don't wait. Ask your questions right away. We want to solve those little issues. Sometimes there's a little tweak we can do right at the beginning of your understanding, and that will make all the difference as we continue to build on your information and knowledge. So let's talk about today. First step, we're going to become boringly good. Always check for the GCF. Always, always, always. Next, we ask ourselves how many terms, and today we're only going to be looking at, or in this section, we're only going to be looking at 2 terms, and this is where we apply special formulas. Either it matches one of the special formulas or it doesn't. If it doesn't, you're done, you walk away. If it does match, you break it down just like the formula tells you to, okay? So special forms for 2 terms, you're going to memorize three formulas or forms. And I've got a deal for you. You really only have to memorize 2 patterns. So you can choose to memorize 3 formulas if you want, or you can break it down even further and just memorize 2 patterns, and then you're good to go. So there's 3 possibilities for 2 terms. There is the difference of squares, which means you've got 2 perfect squares being subtracted from each other, which looks like this if you have something a squared minus b squared. The way that factors, And some of you might remember this because you ended up with a squared minus b squared after foiling when the oi piece, the outside-inside piece, were exact opposites and they fell out. They canceled each other out. That's when you ended up with a squared minus b squared. The reason we're talking about that is because remember, factoring is undoing the multiplication. So what did this look like before we FOILed it out? Well, it was exactly matching factors, a and b. One was plus, one was minus. So this is where you start, you FOIL, this is where you end up. When you factor, you take that and work it backwards. So you want to recognize that when you see something squared minus something squared, whether it's numbers or letters, that is the square root of each term are the factors. One is plus, one is minus. So that's one of the formulas. And we'll simplify this. Difference of squares. We'll note this is DOS, difference of squares. Let's look at the next one. You could also have a difference of cubes, where we're subtracting two perfect cubes, something times itself 3 times, minus another something times itself 3 times. So it would look like this, a cubed minus b cubed. In other words, this is a times a times a, this is b times b times b. Okay? Now this is not one necessarily that you would have noticed. This is one that we are giving this formula to. We wouldn't expect you to come up with this on your own. But this factors into 2 terms as well. You've got a small piece, a 2-term, and a big piece, a 3-term. Okay? You've got a small and a big, a binomial and a trinomial. So you need to remember that the cubes have a little bit different look to it when you break it out. But you start with your a and your b like you would on the difference of squares. You then square the first piece. This becomes a squared. You square the second piece, b squared, and in the middle of that trinomial, you multiply them together, ab. So to factor this, you put a and b, whatever the cube root is of your 2 pieces, a and b. Then take a and square it, put it in the beginning of your trinomial. B and square it, put it at the end of the trinomial. Multiply a and b together and put it in the middle term of your trinomial. And then it becomes a matter of what signs go in here. And the signs are, for a difference of cube, it's always going to be the same sign that you started with, then the opposite sign of what you see. So the same sign here, we started with a difference, we're going to put that same sign here. Opposite of a minus is a plus, and then this one is always positive or always plus. So same as what you started with, opposite of what you started with, always plus. And you get a little reminder here, S-O-A-P, soap. And the book refers it to as a cube of soap. That's a little bit of a stretch, a bar of soap. When you have cubes, the signs go same, opposite, always, plus. So a nice little way to remember it. And that is the pattern. Once you have that pattern down, you now know the third one. Oh, pardon me. Let's refer to this one as DOC, difference of cubes. So again, what we're looking at is if there's 2 terms, does it match any of these situations? If it doesn't, it's done. It can't be factored. Okay? Again, after you've taken out the GCF. So you can have difference of squares. That breaks down to a plus b, a minus b. Difference of cubes, that breaks down to a and b with the same sign as you see, so a minus b. Then a squared, ab, b squared with the opposite sign you see, so plus, and then always plus. So this is how a cubed minus b cubed is factored. And again, that can't go any further. That's done. The third situation, instead of a difference of cubes, it could be a sum of cubes. And we'll call that SOC. So there's DOS, DOC, SOC. And this would be a cubed plus b cubed. It's going to be the exact same pattern. You're going to have an a and a b in your binomial, then an a squared and a b squared at both ends of the trinomial piece. Multiply them together, a times b, and then you fill in the signs just like you did before. Same, opposite, always plus. Same as what you started with, plus. Opposite of what you started with, in this case minus. Always plus is just plus. So you memorize one pattern here, and you've got 2 formulas. So there's your 3 formulas. And I said that's all you needed. 3 formulas, 2 patterns, you've got it. Difference of squares, and then your cube pattern. Whether it's a difference or a sum of cubes, it works. But you might think, well, there's one other situation. Indeed there is. There is the difference of squares, difference of cubes, sum of cubes. Wouldn't there be necessarily then a sum of squares? Can you factor a squared plus b squared? And this one is not factorable. Can't go any further than this. So there is no formula for sum of squares. There's no SOS, okay? So there's no factors for a sum of squares. It cannot go any further. And now we'll practice some problems here in our next video clip.